Alright, so we are starting on 3.3 proofs of parallel lines. This is the next section of the notes after 3.1 and 3.2, and if you missed those notes, please click onto the channel and make sure you watch those prior to this. This part is talking about exploring parallel lines and their transversals. So for the first part, it's talking about the converse statement of corresponding angles theorem, which reads, if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So if I'm to write the converse, and if we remember what converse meant, it does mean to switch. And we're switching the hypothesis and conclusion, which is your P and Q. So the converse of this theorem is if the pairs of corresponding angles are congruent, then two parallel, remember this symbol here, double lines, does mean parallel, lines are cut by a transversal. Now, reading is definitely fundamental, especially reading directions. It says determine whether the converse is true and justify it. So is the converse true for this theorem? And it is. And if we note, hint about most theorems are already proven to be true. So all of these are going to be true when we go through them. But to name some examples of corresponding angles, 1 and 5 are corresponding angles of each other. And if we were to name another set, we also have 4 and 8. And corresponding angles we talked about are congruent to each other. So on to the next one, we have B. It says alternate interior angles theorem. So a lot of these we kind of already talked about. Now we're just adding the word theorem on the end of it in order to prove such things are true or not true. So it says if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. And the converse of this is if the pairs of, and I'm abbreviating alternate interior angles are congruent, then two parallel lines are cut by a transversal. And we noted that all theorems are true, whether we use the inverse or the converse. So the converse of this theorem is also true. And to name two examples, we have 3 and 5. They're on the inside of these parallel lines. So if we think about interior, we're thinking about everything that is in between these parallel lines. So we have angles 3 and 5. And if we were to name another set of alternate interior angles, we also have 2 and 8. Then we head on to C. I have alternate exterior angles. These are very similar, except we are talking about things that are not on the inside of the pair lines. So anything on this side and this side. So we're not talking about what's on the inside, we're talking about the exterior. But the converse is if the pairs of alternate exterior angles are congruent, then two parallel lines are cut by a transversal. And we noted that this is also true. And we have a couple examples. We have 1 and 7. Remember, alternate, we're also talking about the opposite sides of. And then we also have 4 and 6. So these are your theorems that we'll talk about. You don't have to necessarily remember the number because I know I wouldn't, but please just let me know if you're talking about alternate interior angles, and always add the word theorem on the end of it. Okay, so we're talking about the converse of it. So we're talking about if the pairs of alternate exteriors are congruent. So we're proving that they're congruent first, then those lines are cut by a transversal. And the transversal is also that line that's cutting through two parallel lines. So we have one more theorem on the back side. It's talking about consecutive interior angles theorem. So consecutive actually means next to. It's like adjacent. We talked about adjacent being next to as well. So we have if two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary. So the key word is supplementary, and if we remember that one from our previous lessons, we know if we have two angles, we'll call them A and B. If we add them together, they should equal 180 degrees. Okay, so the converse of this statement is if the pairs of consecutive interior angles are supplementary, then two parallel lines are cut by a transversal. Alrighty, and we know that this statement is also true. And to give a couple examples, we have 2 and 5. Note, they're talking about the angles that are next to each other, but also interior, so we're talking about what's on the inside of these two lines. So we have 2 and 5. And we also have 3 and 8. So communicating your answer. So we have 2 and 3. 2 says, for which of the theorems involving parallel lines and transversals is the converse true? Well, if we look back through all of the theorems that we proved and their converses, all of them are true. None of them were false. So all theorems and its converse are true. For the third one, it says explain how you would prove any of the theorems that are found to be true. Now this one I will give to you, but if you thought long and hard, a lot of these angles you can find using one set of degrees. And normally those are a pair of corresponding angles. So if I can assume so it says if I can assume the converse of corresponding angles theorem, and I'm abbreviating theorem as THM, then you can use it to solve for the other three. Okay, so if I know the corresponding angles, I'm usually able to find all the rest of the angles that pertain to it just by knowing those two. So flipping over to the other side, I have definitions and vocabulary words. Now a lot of these we went over in 3.1 and 3.2, and so you may fill this in by rewatching those videos or re-looking at those notes. The only ones I'm willing to give you is congruent, because we kind of dabble on it but didn't really give a true definition. So congruency has the symbol of a squiggly line on top and the equal sign right underneath it. So that is the symbol for congruent, and that is to say that angles are equal to each other. So if I want to give an example, I would say that angle 5 is congruent to angle 4. I will only use congruent if I'm talking about the angle itself. Now, if I want to talk about the measures of them, like degrees, I can say the angle measure of 5 is equal to the angle measure of 4. That's to say if I had, if angle 5 had a measure of 90 degrees and angle 4 had a measure of 90 degrees. So if we're talking about the angle itself, we'll use congruence symbol, but if we're talking about measures that are equal to each other, we'll just use an equal sign. All right, going down to the bottom, we're looking at theorems, corresponding angles, and we know what corresponding angles are. They're in the same position. Think about the same position, but in different buildings. And we're trying to prove that J is parallel to K. So with that, we'll talk about the two-column proof. We kind of talked about this in our last section and pertains to properties, whether that be transitive, subtraction, etc. So let's talk about 2 and 6. So we have 2 and angle 6, and these are given to us. And what do we know about 2 and 6? We know 2 and 6, or 2 is actually congruent to angle 6. And how we know that? We know that by the corresponding angles theorem. Okay? And if they're congruent to each other, means their angle measures are actually equal to each other. And we can say that using congruency. When we say something is congruent to each other. Now let's say if we wanted to give these a value. Let's say angle 2 is 3x plus 5 and angle 6 is 65 degrees. Then I can use substitution. I know that 3x plus 5 will equal 65 degrees. And we can do the work. I'll put it over to the side. 3x plus 5 is 65. 3x will equal 60. And when I divide by 3, x equals 20. Note you can add this to your proof and give me the properties that we use, such as subtraction and division. And you'll get x equals 20. And so for over here, I have x equals 20. And using the corresponding angles theorem and congruency, we know that J is parallel to K when x equals 20 using corresponding theorem. Okay, if we flip over to the next side, we have alternate interior angles and it's converse. So we have angle 5 and 4, and we're proving that J is parallel to K. So I have angle 4 and angle 5. These are given to me. And angle 4 and angle 5 are congruent. And we know this by alternate interior. We know this by alternate interior angles. Let's say we had angle 1 here. What can we say about angle 1 and angle 4? These are also congruent to each other. So that means angle 1 is also congruent to angle 5. And this, I actually use transitive property. But I also know this because 1 and 5 are also corresponding. So J is parallel to K based on the corresponding angles theorem that shows me there are alternate interior angles involved. Now see if you can do the same thing for 3.7. It's very similar to 3.6, except I have exterior angles involved this time. So say we have 2 here. How would you prove that J and K are parallel to each other? So then let's look at 3.8, consecutive interior angles and its converse. So I have 3 and 5, they're on the insides, and they're supplementary. So I have angles 3 and 5 are supplementary. Now I am abbreviating, and this is given to me. What is the definition of supplementary? That means if we add them together, they should equal 180 degrees. So you can use also the definition of supplementary. And with that, we also know they are same side interiors. So we know that J is parallel to K using consecutive interior or same side interior. Okay. So we were going to talk about more about the transitive property of parallel lines, but this is self-explanatory. We talked about transitive, and we're saying that all 3 of these are parallel to each other. So if P is parallel to Q and Q is parallel to R, then P is also parallel to R. Flip over to the back side. I have exercises 1 and 2 to find the value of x that makes m parallel to n, and you're going to explain your reasoning. So I have 95 degrees and 8x plus 55 degrees. I know these are corresponding angles. And I'm abbreviating. These are corresponding angles, and corresponding angles means that they are congruent. So I will set 8x plus 55 equal to my 95 degrees. And so when I subtract 55, I have 8x equals 40. When I divide by 8, x equals 5. Now I also have 200 minus 2x and 130 degrees. These are alternate interior or alternate exterior angles because they're on the outsides. And what we know about alternate exterior angles, they are also congruent to each other. So I have 200 minus 2x equals 130. When I subtract 200 from both sides, I have negative 2x equals 70. Negative 70. When I divide by negative 2, x is a positive 35. So for exercises 3 through 6, you're going to decide whether there's enough information to prove it, and then tell me what theorems you used. So do I have enough information to show that these are parallel to each other? These are corresponding angles, so based on the corresponding angles theorem, yes. Okay. Now 4 is talking about, are they vertical? Or they're actually vertical angles, but is it enough to tell me that M is parallel to M? No, they are not, because I only have vertical angles when we're talking about the theorems that we were given. So see if you can do 5 and 6 on your own. Do I have enough information to show that I have M that's parallel to N? And that is the conclusion of our notes, and thank you so much.